In this example, which is a perfect exam problem, we have a NAND gate latch. So what we have to remember about NAND gate latches, of course, what we have to remember about NAND gate latches is that a NAND gate latch means that we have to drive S equal to 0 to set, and we have to drive R equal to 0 to reset. That's just the nature of a NAND gate latch. So these waveforms are given. So this is the question. This is the question. The question has set and reset happening in this manner over time. And it is initially setting at the state Q equals 0. So for this NAND gate latch, we have to know what it's initially being set at. All right. So what is find the output waveform? What does output mean? We know that a latch has output of Q. And what is Q going to be? Latches also have Q inverse, but that's just the inverse of Q. So what I mean by what is the output is what is the output Q? Well, Q is going to be either 0 or 1 because we're in our digital theory here. And if we had anything other than 0 or 1, then we're probably doing something wrong. Initially, it is at the state of Q equals 0. If you are not told in the question what the initial state is, then you have a problem. You need to be told in the question, what type of latch is it? What are the input conditions? And what was the initial state for Q? Because it has memory, right? So its output depends on the memory that it already had. So initially, Q equals 0. And what we have to do when we're answering one of these questions is we have to say, okay, well, it's going to be in that state until something changes. And something changed here. Something changed here. Something changed here. Something changed here. Something changed here, 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 and here. And once you get good at this, you can just go through and sort of identify all of your changes. So at this first, at this initial condition, let's do this one. We have a 1, 1. And then at this next condition, we have driven R to 0, right? And then, so we drove R to 0. So here we go. We started at 0. Now we're driving R to 0, which means we're going to reset the latch. To reset the latch, reset means Q equals 0. So now I'm going to reset that latch. I'm already reset, so I reset it again. Now I drive R to 1. Does that mean I set it? No, I drive set to 1. Does that mean we set it? No, because we can only set it if we drive S to 0. And at our next break, look at this. We drove S to 0 here. That's really important. We drove S to 0. So we're starting, we stay at 0 because 1 did nothing for us. We drove it to set. Set means Q equals 1. So we just set that latch. And then we put it back to 1. Do I set a NAND gate latch when S equals 1? No. I hold until this is a 0. I want to set that latch. Now let's set that latch. Oh, I'm already set. I'm already set. Q equals 1. So I'm going to stay set. I'm going to stay set. Cool. Then what happened? And then, so I wanted to set it. It was already set. I dropped that. I pulled it back up to 1. I don't care because 1 doesn't do anything for me, right? So I still say set. And, then I drove R to 0. Look, I drove reset to 0, which means seriously, I want to reset that latch. And then nothing else happens in terms of forcing sets and resets. And we just have to make absolute sure that we go to the end of this whole timing diagram. So the answer looks like this hat here, because honestly, once you get used to this, all you care about is when S equals 0 and R equals 0 in a NAND gate latch, I wanted to reset here. I set here. I wanted to set here. I wanted to reset here. But if I were already set, then this one was sort of a moot point, right? I was already reset. This one was kind of a moot point, right? So I was reset, then let's grab a different color. I started reset. I tried to reset it. I was already reset. I tried to set it, so that worked. I tried to set it again. I'm just pressing the button. It's already set. And then I try to reset it. There we go. We got it reset. Perfect. So that's an example of a NAND gate latch, setting and resetting the NAND gate latch over time.